That's right. Okay. I think recording has started, and so we should be good to go. Thanks everybody for joining us for the requirements engineering session number 2. We've got 5 presentations for you today. All 5, each of them 5 minutes. We'll be running them back to back, and then all questions and discussions will follow the final presentation. Nice to see a big bunch here. We'll start off with our first presenter, Colin. Do you want to start sharing, and then I'll introduce, so we've got Colin Werner, who's presenting their work on continuously managing NFRs, opportunities and challenges in practice. Handing over to you.
All right, so welcome everybody. So I'm Colin Werner. I'm a PhD candidate at the University of Victoria. Today we're going to talk about continuously managing NFRs. So what that means is how an organization manages their non-functional requirements in continuous software engineering. And so through our research, we came up with 4 practices and 3 challenges that we observed from these organizations. So these are real industry organizations that we studied. I won't get into the details. If you want to read about those details, you can find them in the paper. So we'll start with the 4 practices. So the first one is to put a number on the NFR. And the first practice for dealing with NFRs is establishing metrics to help validate and assess a particular NFR. The concept of NFR metrics was frequently discussed throughout our interviews. When an organization tracks pertinent metrics for NFRs, metric indicators collected by the organization's deployment pipeline provide valuable insight on NFRs. One critical success factor for putting a number on the NFR is the associated quick feedback loop with continuous software engineering, which enables an organization to continuously monitor their metrics. And obviously, as I mentioned, the feedback loop is an integral part of continuous software engineering and is one of the biggest perceived benefits of adopting CSE. So the second approach is let someone else manage the NFR. This is probably the most popular approach to managing NFRs that we found. And it's simply done by the organization offloading an NFR, or at least part of an NFR. And in this case, that someone else is typically a large cloud service provider such as AWS or Google Cloud. So offloading the NFR means that the organization allows another platform or a tool to realize at least part of the NFR on the organization's behalf. This allows the organization to focus on their core functionalities and behavior of their software, so they don't have to worry about NFRs such as scalability, reliability, etc., depending on what the organization deems important. However, we found that offloading an NFR is not as simple as flipping a switch to realize the NFR. In many cases, in most cases, some form of configuration management is required. And then obviously ensuring that your system is designed for this sort of configuration. The NFR offloading also, we found, provides the capability to ratchet NFRs, as we saw it all through organizations. So the third practice was write your own tool to check the NFR. So this is kind of the opposite of offloading an NFR to a third-party service or tool. This is where the organization would write their own custom in-house source code or tooling or scripts or even manifests. However, we found that with resource-constrained organizations, the custom tools are usually the last resort, where existing off-the-shelf or open-source solutions are usually preferred. And then the final practice is put the NFR in source control. So at the organizations we studied, the workforce was constantly changing, typically growing, and the products were experiencing a rapid pace of change. The constant change requires that developers gain a clear understanding of the NFRs of the product, so they know how their changes might impact these NFRs. So another aspect of this is codification, which refers to using code and related artifacts to capture NFR knowledge. So on to the 3 challenges now. So first, not all NFRs are easy to automate. Obviously, there's potentially an infinite number of NFRs out there, although maybe not that many, but there are many, many different ones. And there's no silver bullet used to automate them all. So there's no one solution to automate them all. In addition, some NFRs are more difficult than others. And unfortunately, adopting continuous software engineering approaches to development, which means committing and deploying at an extremely rapid rate, appear to make this an even greater challenge. And part of that is our second problem or challenge, which is functional requirements over NFRs. Again, since our collaborating organizations are still growing rapidly, employees balance many other opportunities or responsibilities, among other limits of potential resources. And in these resource-constrained environments, NFRs are an easy target to bump from sprint plans or milestones due to a lack of clarity around how to verify or even define the NFR. And then finally, we found that a lack of shared understanding of an NFR implies that everyone involved with an NFR is in agreement with the meaning of that NFR and its various components. This shared understanding relies on knowledge transfer from the people, such as the product manager, who created the NFR, to those who might affect. Shared understanding is a challenge for all of our subject organizations. They face problems with inconsistency in what gets explicitly stored in source control, with tacit knowledge and a low bad or circus factor, and problems with role siloing. So there we go. That's the 4 practices and 3 challenges associated with managing an NFR and continuous software engineering. So thank you.
Thanks very much, Colin. We'll save the questions to the end, and we'll move on to the second presentation, which is also, I should have said that was a journal first, and the second one's also a journal first. So we've got Rahul Mohanini.
Yes.
Right, I'm happy to bring it to you.
Hello, everyone. A very good evening from Finland. I am Rahul from the University of Jyväskylä, and let us dive straight into our paper. So let's have a look at the problem. So during an ongoing project, we were observing a team responsible for developing a mobile application. The client initially gave us a list of very unclear features, instructions, which were presented as requirements. The developers began coding the system, and the clients didn't like the design, and they rejected the system altogether. We observed the following plausible reasons. Well, most of these requirements were deceptive. However, the developers immediately accepted the requirements, perceiving all of them with equally high importance and confidence. We speculated that the way in which the specifications were presented affected developers' cognition and their design performance. This process can be explained by framing effect, which is a type of cognitive bias. And so we wanted to investigate whether designers might be fixating on specifications when framed as requirements. So what's the context of our research? So to test our hypothesis, we first conducted 2 experiments, which are not a part of the main part of this paper. In these experiments, we compared the list of specifications framed differently, first as requirements, and then as prioritized requirements against ideas on creativity, which we measured in terms of originality and practicality of designs. The results of both the experiments showed that designers fixated on specifications when they were framed as requirements, which reduced their creative performance. However, these experiments were not then suitable to understand the cognitive mechanisms underlying these causal effects, and we needed a real-time insight into software designers' cognitive processes. So hence our research question: how do fixation and critical thinking explain reduction in design creativity? So we conducted a dialogue-based protocol analysis where participants worked in pairs or groups and verbalized their thought sequences while performing a task. We had a convenient sample of 18 professionals and 24 postgraduate students. We used the same task as our previous experiments, where the participants were asked to verbalize their thought sequences while creating mobile applications, given a list of requirements. The recorded dialogues were transcribed and analyzed in 2 phases. First, inductive process coding, and second, deductive close coding. We then compared and counted the number of instances of fixation and critical thinking. The findings. Well, the process coding produced 7 themes, each one of which we interpret as a distinct cognitive activity. We then found 1,006 instances of fixation as compared to 298 instances of critical thinking. We also found that both students and professionals seemed equally susceptible to fixation, Also, more experienced developers were more prone to fixation. Hence, the conclusion. We then conclude by proposing the theory that by providing designers with templated requirement specifications, which are requirements presented in a very formal and a structured way, induces requirements fixation, which is kind of a cognitive bias as design fixation, which hinders their critical thinking. This affects the creative potential of designers, hence inhibiting the creativity of the designs. Thank you very much. That was a very brief abstract of our paper, almost, and happy to take any questions later on. Thank you very much.
Thanks very much, Rahul. Now we'll move on to our third presentation. So Smita, I believe you're there. Yeah, perfect, great. So we'll move on to the third one, which is software engineering practice, automated labeling, classification, business rules from software requirement specifications. Do you want to start sharing your screen? I think you're muted, so I can't really hear if there's any issues with the sharing. We can't hear. Do you try to click on mute? Maybe, I don't know if you can try the chat, if that's, otherwise we'll probably have to, what we could do is potentially move to the, okay, great, I can see a share. There's just no sound. Are you familiar with any issues that might help? Because what we could do, we could potentially move to the fourth presentation and then come back. If you just, oh. Oh, I think just in the respective, oh yeah, I mean, we can see the slides, but I wonder whether they can hear you maybe. Is she on mute?
I think just on the unmute icon on the bottom, that's below the panel. You're clicking on your name, that'll open up your profile.
I'm not sure she's here anymore. Okay, I think just in the interest of time, we'll skip and then we'll come back to that presentation. And if she's not back by the presentation, we will play the video for it. So Mariam, are you ready to jump in? All right, thank you very much. Okay, thanks. Thank you very much, Mariam. So we'll move on to the fourth presentation, which is how to debug inclusivity bugs, a debugging process with information architecture.
Hey, can I?
And then we'll come back to Smita. Oh, there you go.
Oh,
Just in
I'm so
time,
sorry.
Smita.
Okay, I'll wait my turn. Thank you.
Do you want? Yeah, okay, that's fine. If you don't mind waiting, and then we'll have Mariam start.
Yeah.
Okay. All right, thanks. Okay, there you go, Mariam.
Share my screen. I hope you all can see it.
Yeah, that's good. Yeah.
Perfect. Okay. Hi, my name is Mariam Ghizani. I'm a PhD student at Oregon State University, and today I'll be presenting our paper, How to Debug Inclusivity Bugs, a debugging process with information architecture. So diverse teams have been shown to be more productive as well as more innovative. And one form of diversity is cognitive diversity. And this helps generate diversity of thoughts. However, cognitive diversity is not often supported in software tools. So software tools are not always inclusive of individuals with different cognitive styles. An example of this would be those who like to learn through process versus those who like to learn by tinkering. And this creates what we call a cognitive tax. Now, what are inclusivity bugs? So inclusivity bugs are biases in software that could introduce inequities. And these could be showstoppers, but they don't have to. They could just be increasing the cognitive load for somebody to use a software or go through a project. Now, let's take an example. Here's Sarah, a learner. She does not like to tinker, and she has little spare time. She's a chemical engineer student. She's doing her capstone project, and she finds an OSS project that she can reuse. She gets really excited about it, and she tries to set up the environment. But she gets confused and lost during this process. So she tries multiple times to find the information she needs, but she feels like she's wasting time and ends up abandoning the project. Now, this is unfortunate because it turns out all the information that she needed was actually there. But it was so fragmented and disorganized that it made it impossible for her to find and use. So this is one example of an open source project, which is the scope of our study, that hinders comprehensive and process-oriented users. Now, I'm going to introduce this method, which is called GenderMag, that we use in this process. So GenderMag is a cognitive walkthrough, a specialized cognitive walkthrough that has 3 personas, Abby and Tim, at 2 different ends of the spectrum, and it has 5 facets that are listed here. So I'm just going to go through one example of one facet, which is learning style. So for instance, learning style for Abby, the value would be that an Abby-like persona would learn best through process-oriented learning, like processes and algorithms, not just individual features. However, Tim-like persona would learn more through tinkering, and they sometimes get lost during tinkering and backtrack. Now, what is the process that we present here? So it's a systematic inclusivity debugging process that we call why, where, fix. So the why part is about finding the inclusivity failure, which is analogous to testing. But because this is not tied to a wrong output, we need to specifically discern why the observed phenomenon is considered as an inclusivity failure. And this is where GenderMag comes in. Now, the where part is what ties the inclusivity failure to the fault. And this is analogous to fault localization. And this is where information architecture comes along. And information architecture is about how information is structured, organized, labeled, etc. Now, we take on the why and the where, and we produce the fix in a more systematic way. Our methodology approach was twofold. So we did a field study with an open source team that took the why, where, fix process and applied it on their project. So they went from an original project, found 6 inclusivity bugs, fixed them, and got to a diversity enhanced project. We then took these 2 projects and did a lab study with student participants to evaluate the original project versus the diversity enhanced. Now, our results are as follow. In these 6 inclusivity bugs, the total number of bugs encountered in the lab study in the original project was 20, and it went down to 2 for the diversity enhanced project. So the why, where, fix here reduced the total number of inclusivity bugs by 90%. And you might ask, what about inclusion? Let's take a look at this table. So this introduces the inclusivity summary. So the effect on the Abby-like above, which are the orange icons, facet values, and the Tim-like facet values. And we can see that here, all of them, all the effects on these values, the fixes effects were positive, showing that the IA fixes increased the inclusivity of the prototype across all cognitive styles. And this made that the IA fixes made the project more inclusive. And one important thing to note here is that the fixes were targeting the Abby facets, but they also helped Tim's facets as well. Now, another question to ask is, well, what about equity? Did the fixes help with equity? Well, a definition of equity is the quality of being fair and impartial. Now, let's take an example of bug 1 and 2. In bug 1 and 2, in the original project, 5 of Tim's facets were affected, and 14 of Abby's facets were affected. So we can see here that the original project was unequitable, very unequitable. The difference is big. Now, after the fixes, 0 of Tim's facets were affected, and 2 of Abby's facets were affected. So we can see here that the difference got reduced quite a bit. So the fixes here made the project more equitable. And another thing to note as well is that also Tim's facets went down to 0, even though the fixes were actually applied for Abby. Now, to conclude, we present the why, where, fix process as a way to debug and fix inclusivity bugs. We also show that the IA fixes reduced the number of inclusivity bugs that the participants experienced by 90%, increased inclusivity and equity. And one thing to note is that using this process does not support one population at the expense of another, but instead it produces positive effects across diverse cognitive styles. Thank you very much.
So I can see in the chat quite a lot of questions for everybody who's presented so far, but again, I'll definitely come back to them in order later on. Shall we try Smita now before we move into Alan and as the last presentation?
So please let me know if you can see my slides and you can hear me as well.
Oh, we can hear you good. We can hear you well. It's just now about the slides.
Right,
now.
thank you. So, okay, thank you for this opportunity to present. Smita, I'll be talking about automated labeling and classification specification. The idea behind this work is really to automate activities that would take business rules closer to implementation. Purpose, what we do is the following. In our previous work, we have established links between, that is Ross's business rule classes and implementation. So for example, take the rule statement that is displayed here. If a claim payout is less than a certain amount, person holding a certain designation can waive off certain requirements. This would be classified as an inference rule according to Ross. What we do is process this and bring in implementation specific angle by saying that this actually means that you need validation and access control. So this is what we mean, a business rule closer to implementation so that software engineers can implement the rules correctly. So what we do when we attack this business rule disambiguation problem is we identify them from software requirement documents, then we classify them using raw schema, and then further link them to implementation specifics. Now, in accordance with our mission of machine first, we try to automate as many software engineering activities as possible. And therefore, in this particular work, we move a little bit leftwards. We shift left, and we try to automate the generation of labels for our training data set as well, thereby creating a pipeline of automation from labeling all the way to classification. This is also part of our project where we create scalable AI solutions. As all of you must be aware, major bottleneck in implementing any AI solution is labeling. So let us go to some of the details over there. Here is an overview. Finish this in flat 5 minutes. So what we do is present an approach to automatically label and classify business rules along raw schema. We use data programming as implemented in Snorkel for generating labeled training dataset. Then using this automatically labeled dataset, we train 2 deep learning based models, BioLSTM with attention and BERT. And then we evaluate the approach on industry specific dataset comprising of BRs from various business domains. Now, here is a little bit about data collection and labeling. So we recruited in-house subject matter experts. 3 of them extracted about 6,000 business rule instances from publicly available data sets, which were software requirement documents. And then our subject matter experts essentially labeled 712 business instances manually by inspecting each business rule sentence. And then we employed Snorkel to automatically label the remaining 5,000 plus instances of the business rule instances derived from the public domain. How did we go about doing that? How did we do the label generation? We created labeling functions. Labeling functions, as you know, are essentially ways to capture the weak supervision. They could be keyword based, or they could actually be wrapping traditional machine learning models or deep learning models. So we took some combinations at a time, and we basically performed analysis of these LFs, looking for high coverage, high accuracy, and high overlap and low conflict. And having done this analysis, we selected the top 14 labeling functions on the basis of the accuracies. The accuracies are displayed in this table over here. So these are the ROS classes in the left column and the accuracies that we obtained using these labeling functions. Then we wanted to validate the SNORKEL label data, because how generalizable are our LFs was a question. So to validate the generalizability of the LFs, we looked at the BR classes on which the LFs were based. And essentially, again, we hired 3 domain knowledge experts, and we shared 7 BR classes along with their definitions to them and asked them to say whether they seemed domain agnostic or domain specific. So all 3 of the domain experts of the opinion that the 7 BR classes that we took were domain agnostic. They were likely to be present in all the domains. But some of them also pointed out that those classes may not cover domain-specific classifications, such as, say, indemnification in insurance or remedial criteria in medicine domain, healthcare domain, and so on. So overall, from this validation, it seemed that it was reasonable to say that the heuristics that we captured in LFs were generalizable to other domains as well. But it is possible that we may need to create some additional LFs to make our approach work for applications in some very specific domains which we haven't covered. So those were the pointers. Then coming to business rule classification itself, we took this automatically labeled a data set, and then we used it to train 2 language model classifiers. So we did the standard things that one has to do for pre-processing, for example, and we trained 2 language models, BioLSTM with attention and BERT, as I mentioned earlier.
Oh, you've got a minute.
So got some results.
Okay.
Yeah, so this is my last slide. So this is we employed weighted score because the ratio of BRs and non-BRs was 1:5 in our data set. So we are reporting FY scores. You can see here that the BioLSTM attention model basically overtook BERT. It outperformed BERT. And that this could be because of the size of the BR data set. BERT works well with 100,000 kinds of BR probably data instances, whereas we had only 6,000. Class imbalance we had, for example, the BR class term had many occurrences than the rest of the classes. And we also kind of data set. We couldn't use the standard class imbalance techniques to mitigate the issues related to the class imbalance. So these are the results in a snapshot. These are the threats to validity, which have been discussed in our paper: comprehensiveness of the classes, generalizability. We already discussed the comprehensiveness of data set, reproducibility claims. Our future work, of course, includes dealing with class imbalance. Then the simultaneous multilabeling of ST artifacts is another interesting problem that we are working on. Its work in progress will be presented in the coming RE conference. And data variance, essentially stepping out of the standard software engineering domains and testing our approach on other domains which haven't been included in our data set so far. So that's it.
Thank you very much. Thanks, Mita. Presentation. We'll move on to our last one, Yaron. And so that's a paper from the technical track on generating visualizing trace link explanation.
Sure.
Yeah.
Okay.
That's all good.
Hello, everyone. My name is Yalin Liu. I'm a PhD from University of Notre Dame. Today, I'm present our paper, Generating and Visualizing the Trace Link Explanation. Software traceability is a technique to recover and mine the relationship among those software artifacts. However, manually finding the true link is very expensive and time-consuming. Researchers therefore proposed automated trace models to reduce the manual efforts. However, the generated links are not widely adopted in production. From our perspective, there are 2 causes for this phenomenon. The first cause is the generated link don't have enough accuracy. The second and the most important cause for us is that the lack of explanation. Giving the following example, which is a link between the requirement and the design definition to artifacts. The argument drive stamped message are closely associated with terms such as carry, velocity, and angles. And the task plan always involved with moving planning. If people without such knowledge may have difficulty to understand why those two artifacts are related. So in our study, we identified the trace link explanation from two aspects. The first aspect is the artifact explanation. We think explanation should help reader to comprehend the artifacts by explaining the domain vocabulary. The second aspect is the link relation explanation. We think explanation should help readers to understand why the two artifacts are related. And our target user are the newcomers to the project and also the stakeholders who trace widely across artifacts using different terminology. So for this purpose, we proposed 4 types of explanation elements. From the artifact semantic, we extract the acronym expansion, concept definition, and context usage. The acronym expansion, we map the short format of the concept to its full name. And for the definition, we find the sentences which define the meaning of the concept. And for the context usage, we provided examples of how using the concept in the domain sentences. And for the link explanation, we extract the concept relations from corpus and present them as tuples. And the tuples contains one concept as subject and one concept as object, and the verb between them indicating the relationship. And here is the workflow of our method. Firstly, given the artifacts, we firstly collected the sentences from the artifacts to create the project and the corpus. And then we apply the concept detection method to identify the non-concepts from the object or from the project. And in the step 2, we elect the domain-specific concepts by using the general concept blacklist created from the UMBC corpus. And in step 3, we apply the domain concepts to guide our corpus collecting task. We have 2 approaches. One is the top-down. We use the concepts to retrieve project-related corpus from large corpus. And the second approach is the bottom-up. We use those concepts to search the corpus from the scratch. And after collecting those domain-related corpus, we conduct NLP analysis to extract the 4 types of the explanation elements. And we also train a quality control model in step 5 to help us remove and filter the low quality content. At last, we present those explanation elements to user with a graphic user interface. Finally, our user interface organizes the explanation elements in the following form. The UI integrated and display all 4 types of explanation elements mined by our techniques. Users can use mouse to click the concepts and to show and highlight the explanation and the relation. And our explanation elements in the UI are then evaluated in the user study. We ask user to write links with and without explanations. We observe the user performance is significant better than they are supported without when they are supported with our explanation. And we also conducted quantitative evaluation to the explanation elements. For the term consideration, we only show the definition and the context evaluation here. In both tables, the top-down method extracts more elements than the bottom-up. However, the bottom-up provide results with high accuracy. The main error made by the top-down extraction is including some sentences from irrelevant domains. And in the end, from the experimental result, we conclude that our approach works best in the domain supported by the large corpus of public documents. And second is it can provide complementary explanation in addition to the project glossary. Third is the main bottleneck for our approach is the sparsity of the explanation elements in the corpus. So that's the end of my presentation. Thank you for the listening.
Thank you very much, Yalan. Thanks. Fantastic. Thanks to all our speakers for their presentations. And now we've got about 25 minutes open to questions. There are some questions that are listed already in the chat. To be honest, I'm not sure whether people are able to unmute and ask, but I think I'll start off with at least the questions in the chat. So maybe I'll start off with the order in which people presented. So for Colin, there's a question by Matthew on the second practice you mentioned. So some NFRs might be infeasible without hardware resources of large companies like AWS, scalability, availability. Did you find instances of NFRs where there was a more legitimate choice without being forced to offload it to another company?
Yeah, thanks, Matthew. So two things. I don't think any of the companies were forced to offload their NFRs. It was more of a conscious choice in that their organization wasn't concerned about availability or scale. Well, not that they weren't concerned about it. It wasn't the revenue generating portion of their software. So they could easily hire AWS or whatever and just put some more quarters in the machine and get those NFRs. Now, of course, there are many other examples, but they tend to be specific to the domains that the organizations were using, except for those cloud-based providers. Pretty much everyone was using those to some extent. But there are some trivial examples. So, things like maintainability, everyone knows about, linters or static analysis tools. So that would be one kind of trivial example where you don't require any sort of software to offload an NFR. So really, the idea here is that an organization, not the organizations we were studying, but one of the organizations that wants NFRs offloaded to them, they specialize in a particular NFR. So they pick something and they specialize it and develop a tool or develop some sort of, whatever it is that is needed to actually facilitate the offloading of the NFR, or at least part of it.
Thanks for that, Colin. A question from Miriam to Rahul. Can you elaborate some more on requirement fixation by experienced versus less experienced designers?
Thank you, Miriam. And I kind of tried to answer that in the chat itself. However, let me just say it once again. So, this was not the whole point of our actual analysis. We did kind of an ad hoc analysis to test, like we had professionals and we had students, and professionals are more experienced than the students, and we wanted to see whether they are more or less fixated than the students. And we found that the more experienced the practitioners were, the more fixated they were, at least statistically. So we are not trying to kind of say that this is a really heavy, big sample set of the data that we had, but at least it showed that experience itself might not be able to mitigate fixation. And, the more experienced designers or developers get, the more fixated they might be, or at least our sample set showed so. So this basically, in a nutshell, what I wanted to say.
Thanks very much, and apologies if I've not scrolled down quickly enough to see who's responded. But I think maybe this has not been answered yet from Colin about, can you give an example of one of the inclusivity bugs and then an associated fix? The first example with CheckMate students seems more like a documentation issue as opposed to an actual bug.
Yes. So actually, this was one of the skipped slides because of time, but I can share really quickly if that's okay. Okay. One of the examples is, this is kind of similar to that example of setting up the environment. So because this is about like the bugs that are found are project specific, like open source, for an open source projects that don't have anything to do with, say, GitHub or GitLab, not the platform it's on, it's the project. So a lot of it ends up being about documentation. And this is one example where it was actually about finding information to set up the environment, where the fix was about adding specific keywords, which are the label index terms in information architecture, and then restructuring to add like another layer of hierarchy, and then reorganizing it more like in a specific, using a specific scheme, whether it be task or topic. And here they chose to reorganize topically. And this was one of the fixes of like one of the bugs. The paper has like more examples of a table of what the bug was exactly, what the facet was, or the facets, because there could be multiple, and then what the fix is. We could go ahead and share. I don't know if I answered your question, Colin.
Well, I mean, I'm just trying to think, as a software developer, I've never really come across something, that I've thought about this before. So I'm just thinking like, am I writing code that is, incurring these sorts of inclusivity bugs, and how do I avoid doing it? I guess, I'd consider that kind of they're not necessarily functional, or maybe they are, I'm not sure, but, how do we train developers not to write bugs like that, or be more inclusive in their code?
Mm-hmm. Actually, yeah. So you talked about usability in the NFRs, right? And you can think of inclusivity bugs as, if usability is the big set, inclusivity bugs are a subset of those usability bugs. Because a usability bug could be the font is too small and everybody is hurt by that. But then an inclusivity bug is a little bit more specific, where it's a specific facet. Say I prefer a more process-oriented learning style. Like I prefer to see some instructions and see kind of a very clear workflow of where I'm going, and get some feedback along the way that I'm doing the right thing. And when that's the case in a software or an open source project, or even just a website does not provide that, then it's hurting that subpopulation, and it's just creating more of a cognitive load on them to go through a specific use case. And this doesn't have to be with code. It could be that the workflow and you have to fix your backend, but it could also be a UI thing, or a way information is structured. And because the open source projects, it's like the way they lay out their information, they're contributing.md, the way they label things to guide somebody to take on a specific task or to start contributing. Because that's very like information heavy, a lot of these bugs in this context, in this scope, ended up being about the documentation. That's where information architecture comes in, to go with like small tweaks that just make their life easier, if that makes sense. Yeah.
Yeah, thank you.
Thanks for that. We've got a question from Liliana to Miriam as well. It'd be interesting to understand what aspects of the information architecture lead to inclusivity bugs. Can the wide dimension also relate to ambiguity in the requirement specification?
Oh, can you repeat maybe the second part of the question?
Yeah, so it says, can the wide dimension also relate to ambiguity in the requirement specification? I don't know if Liliana can unmute as well, if you want to elaborate on that. Maybe not, I don't know.
Yeah.
I'm trying to unmute, sorry. Yeah, it took a few seconds to do that. Yeah, I just wanted to clarify. So I wanted to see which issues in the architecture can lead to inclusivity bugs. And sometimes when the requirement specification is ambiguous, then not all edge cases are included in implementation, and that may lead also to inclusivity bugs. And I was wondering if you had any thoughts about this aspect.
Yes. So for the first part of the question about which parts of the information architecture were problematic, so you have like 4 systems in the information architecture where there's like the organization system, and there's the labeling system, and there's the search system, and and there's like the navigation system as well. So different bugs could be attached to a different aspect of the information architecture, where it could be like the whole scheme of the project, like they need to organize the information a certain way and follow a specific scheme, follow a specific either like by topic or by task, and that was problematic because then it was confusing for someone who's going through this. Let's say, take the example of setting up the environment for the first time. The labeling, for example, labeling headers and labeling links a certain way just made a difference when they were more explicit. So these are small little tweaks on the information architecture that could help. And then about the ambiguity of this as an NFR, this is actually really interesting because if there is no requirements for that, because when you're set, this scope is open source, so there's no specific really requirements of how to organize your open source projects. So the owners of the project or whoever's working on the project would go about organizing it the way they see fit for themselves, and kind of like developers, like they tend to develop software the way they understand software, and that's where the missing link happens. That's where it's important to see that, okay, the way I process information might not be the way that everybody else processes information. So I need to test this, and I need to, just like you test your code against different tests and different texts that might generate a bug, a code-related bug. You want to test your software or your project against these inclusivity bugs and make sure it's covered as well.
Thanks, Bertie, for that. Liliane, do you have any follow-on on that? Or, I'm not sure if so. I don't know if anybody else has any questions. I'd welcome people to unmute and speak up and make it much more feel like there are people behind the faces. I might have maybe one question for Yalan here, just on the traceability. I was just a bit curious in terms of with generating the TraceLink explanations, whether that was in any sense independent of the method for generating traceability links in the first place. So whether you had a uniform way of generating explanations for the trace link, regardless of how those trace links were generated in the first place.
Actually, there is no explanation in the traceability before, so this is a very naive idea we firstly get, and we define the explanation elements for the trace link.
Okay. Thanks. I think there's another question from Matthew. Would you like to? You might as well kind of, you can say it if you'd like to directly.
Sure. I was just pleasantly surprised about, trying to fix bugs for one persona as having no effect on the sort of opposite persona. Do you think that might be something that would happen most of the time? In which case, just having this structured, explicit way to find inclusivity bugs would generally help for everyone? Or do you think a company might need to go through this process for one persona at a time, possibly having to find trade-offs between different personas? Yeah, maybe it's a vague question, but what are your thoughts about combining all of these together?
Those are really good questions, Matthew. So one of the things we notice is that, well, Abby is the one persona that is usually used to find these inclusivity bugs, just because the Abby traits are the ones that get overlooked the most in software. So that's what usually people would start with. This doesn't mean they can't run the TIM persona or the PAD persona to get more of a coverage. But most of the time, what ends up happening is when they do fix for Abby's facets, they're not, and that's the goal as well, they're not hurting any of TIM's facets or any of the other facet values. And a good analogy for that are like, when you have those curb cuts, if somebody is using a wheelchair, they benefit from it, and that was the usage for it. But then if someone's going with a carry-on, or if someone is using a stroller, that's situational, and it helps. And it also does not hurt somebody who's just walking around, right? So that's where the fixes need to be tailored toward bettering a facet, but also making sure you're not hurting any of the other's facets. And for software, that could be by providing more instructions, being more clear about your labeling. You're not going to hurt somebody who's more of a tinkerer, who has a high self-efficacy, who just goes about things while clicking. You're not going to hurt that, but you're also going to give a little bit more help the usage for somebody who's more process oriented. Yeah, I hope I answered all of your questions.
No, that was really helpful. I might have a quick follow-up specifically on, let's say, documentation. I think there might be two sort of incompatible ways to organize documentation. One would be the more tutorial-like document where you go through different features or whatever you need to discuss in a single streamline sequence, I guess. And the other one would be to just have a bunch of examples almost in a graph or a cluster to help people really get to the specific information they want. In that case, I guess we could just have both documents, but I could maybe see places where two different personas would be incompatible. Do you think we're just missing some new great ideas, or there might be these kind of obstacles?
That's a good point. I would still think that there shouldn't be two documents. There shouldn't be like a TIM document and an Abby document that's out there. And I see Anita really itching to answer the question.
I'm sorry, I need to jump in there, right? Because this is so close to my heart, and I've been trying to be quiet. We really do not want a TIM and an Abby product line, right? Because then we are dividing the world up.
Yeah.
With software engineering, consistency mapping would be a bigger headache. So, and you're spot on there, Matthew, that some of the things like, okay, Abbies need more information, but TIMs like small information, right? So these things might be incompatible. And here is where you have to kind of think outside the box. And one of the things that a design solution we had come across for the documentation is give this question mark and selective, little bit of information that can be expandable, or give expandable tooltips that can be pinned. So the Abbies can take out, put the tooltip, keep it expanded, read through, as the TIMs can move on, right? So you're right. In one of the classes, HCI class, we said, okay, design for Abbies and TIMs. They made it so complicated, it was particularly unusable, right? It was worse for everyone because the students did it, because they put gobs and gobs of information, and that doesn't help. So I think this is where HCI design practices about how to give the information at the right time that matches both is needed. So it's not an automatic dump information.
Great, thank you very much.
We've got a few minutes. I don't know, Colin, if you want to jump in with your question.
Yeah, it's not a question. It's just more of a, if the document, we seem to be, harping on this documentation as part of the crux of the matter here, and whether that documentation could be kind of fluid, where, you start off with, some kind of tutorial that, walks you through it, and, kind of akin to those books when you're a kid that you're reading that, you get to skip to chapter, whatever page or whatever, based on, what your preference is, and whether it could kind of detect or, depict what kind of learner you are or how you want to use the software. And it could kind of, send you down that kind of path, which would be neat if you could use some sort of AI or something there. But
Yeah, there is a facet survey that we used in the study as well to get participants' facets. And that was a good way to check when they're verbalizing how they're going about their use cases, to check which are the facets that were problematic and were hindering them from going. So we had that as a way to see which facets were relevant and kind of compare with also what the bugs problematic facets were. So yeah, so it's not an automated process, but that's a really cool idea to automate the process of knowing which facets it is. But it was more of a facet survey where we collected it and we looked at it while we were seeing who was running through problems.
Yeah, so it seems kind of like a usability survey, as it were, right?
Yes, so it's more of a survey they take in the beginning, and we know where they're at. It also helped us group the two groups in the lab study so that we have actually the same amount, like the same distribution of facets per group. That way we could compare them. Yeah.
Thanks very much. Got a few more minutes if anybody has any questions that they'd like to jump in with.
I have maybe more of a clarification question for Yali. Hi, I was wondering about these concepts that you extract. Can you expand a bit more how you even define a concept? Are these just words from the documents, or do you have a better way maybe to merge synonyms, have multi-terms concepts, these kind of yeah.
Actually, in our paper, we describe how we extract those. We didn't just take the tokens. We decided the concepts as non-phrases. We use some NLP tools and utilizes the NLP tools to identify the consecutive non-phrases as concepts. So this all automatically. Then after we collected those concepts from the project, then we filtered, because if you collect a sentence collect the concept from one sentence, there have the general ones and have the domain specific ones. So in the second steps, we use the same way we accept we capture those concepts from our artifacts and do the same thing in the normal and general context, so we can exclude those regular concepts from the domain-specific concepts. So that's what we get.
And just for my curiosity, can I ask how many concepts do you end up with approximately? Is it 100, 1,000?
Oh no, that's far more than that. And we I don't calculate how many numbers of them. We just have the size of the concept we get, and we use two methods to extend those concepts as corpus.
Okay, I'll go and read that in more details. Thank you very much.
Sure.
Thanks very much, Martin. Thanks. I suppose we'll give people a couple of minutes for the next session. So I just wanted to again thank all our speakers today and all attendees as well for their lively discussions and interesting presentations. Hope to see at least some of you in person. If you do look out, hopefully I'll be there. So I hope to meet you in person as well. If not, then at another ICSE or another occasion. But again, thanks everybody, and hope you enjoy the rest of your day or evening.
Everybody's leaving, so it's too late.